So we want to use jstat to monitor how the garbage collector affects the application. So I've changed our code ever so slightly here. I've changed it so we print out a dot for every 1, 2, 3, 4, 5, 6, for every 2 million allocations. And what we should see on this machine at this time, when I run this code, is that we get about 2 million allocations a second. So the dots print at about the same time that the cursor blinks, and the cursor blinks about once a second. It's only a rough estimate, but about approximately 2 million allocations a second. And remember, this is using the default GC here. So we're using the serial GC. So we're using a bump the pointer allocation to allocate memory. So memory allocation is very, very quick. And the GC runs every so often and collects that memory. If we go back to the other command prompt, and we've relaunched the application, so there's a different PID. So the ID this time is 3956. So if I run jstat -gc against 3956, then we should see the count and information as to what's happening here. And we notice here we are getting roughly the same number of young collects as we are old collects. So 162 young collects, 150 old collects. So the old collect and the young collects are happening about this at the same time. So I'm going to kill the application, and we'll now run this with a different garbage collector. And for this, let's just try the G1 garbage collector. So we do -XX plus use G1 GC, and then run the application again. So the first thing you should notice here is that we are now allocating the objects much more slowly. So as previously we were allocating about 2 million a second, this now looks like it's what? 1, 2, 3, about a third slower than it was previously. And this is because the G1 garbage collector is no longer using a simple bump the pointer algorithm. So we'll notice that different garbage collectors are going to affect our application in different ways. So for our garbage collector, as well as affecting how quickly memory is reclaimed, we also affect how quickly memory is allocated. And that's something that's really important to remember. Now here we have a pathological application. So this application's job is purely to allocate memory. So we would expect to see this sort of slowdown here. If we go back to our monitoring tab and find the ID of the application again, it's now 2876. So I'm not going to clear the screen here. I'll leave the old data on the screen and run jstat against the application, now running with the G1 garbage collector, and see what happens. So I guess there's a couple of things that will stand out here. One is that we've allocated much more memory in the old generation. So we have double the capacity for the old generation. And notice that the Eden and survivor space generation figures tend to vary. So the Eden capacity at one point for this garbage collector is 0. By the time we get to the end, this thing has gone up to 36864, but still not as much capacity as there was for the original serial garbage collector. But the other key thing to note here is how often these garbage collectors run. So the young GC here, at the first time we look at this, we have 490 garbage collects, but only 60 full garbage collects. So the young GC is running at about 10 times the full GC. Whereas for the serial collector, young GC and old GC were happening at about the same time here. So in this scenario, we have much higher throughput of the garbage collector. It's only doing young garbage collects, but we have a much slower allocation of the objects because we're not using a bump the pointer algorithm to allocate our space. So we see there are many things that play into which garbage collector we can choose, we should choose for our application.